Welcome back. Today we are going to see some important multi-threading intro questions. First, what is difference between a process and a thread? We know running Java application is also a process. A process is an independent running instance of a program, while a thread is an execution path inside the process. A process has its own memory space, heap, its own resources, its own operating system context. For example, when you start a Java application, the operating system creates a process thread. Thread exists inside a process and share heap memory, static variable, open resources, code or data of the process. Each thread has its own stack, program counter, local variables, and execution state. So if you run this program, the the main method execution is the process. The thread, it is inside the process. Okay. So next, what is platform thread versus virtual thread? The virtual thread is a concept which is introduced in Java 21. Before that, we always called it as a thread. So platform thread is nothing but OS level thread, virtual thread where it is in the heap space, and the OS thread will be executed in the backend. Okay, in the OS level. So platform thread is a traditional mapped to an operating system thread, conceptually Java thread, OS thread, CPU. Creating thousands of platform threads can become expensive because each thread requires OS resources, stack memory, scheduling overhead, and were introduced as a major feature in Java 21. Virtual thread is managed primarily by the JVM rather being permanently tied to one OS thread. So you have your n number of virtual threads where the JVM scheduler is mapped to the platform thread. You can create n number of virtual threads as it is not a heavyweight one, but it is based on the application, the scenario. You can't use virtual thread for n number of create thousands or millions of virtual threads in all period of time. For example, virtual threads are excellent for high concurrency IO bound applications. For example, HTTP request, database call, and all these things. But there are scenarios where you should not use virtual thread also. I'll explain that later. How does Java memory model work as per of thread? Java memory model defines how threads interacts with the memory. The important concepts are local execution and shared memory. Whenever a thread executes, how the multiple threads are having. For example, thread 1 and thread 2 need a variable which needs to be shared, that is called shared memory. A memory like that particular thread wants to accommodate that variable. For example, I'm having my marks and which should not be known to the another thread is one of a small example. So it is very particular to that thread is called local execution, like thread local. So the Java memory model defines about according to thread is about visibility, whether the should be visible throughout all threads or not. Ordering, how the thread should execute. Thread 1, thread 2, if multiple threads are there, that are ordering. Atomicity rules happens before relationship. For example, if there are two threads, which thread needs to execute at what and how it's visible. So this is the main important point on the Java memory model. Visibility, ordering, atomicity rules, and hypacity happens before relationship. The next one comes here is this is the volatile is about the volatile variable is about the visibility. So if you have seen there the boolean running equal to true, only one thread changes, it will not be visible to the thing also. So the visibility will be So JMM provides ordering visibility through mechanisms such as synchronize, volatile, lock, atomic classes, thread start or join, and the concurrent collections. These are the ways that we can provide the ordering and visibility through the one. So the short answer, interview answer should be: the Java memory model defines how threads read and write shared variables and establishes rules for visibility, ordering, synchronization. Constructs such as synchronized, volatile, locks, and atomic classes establish the necessary happens before relationship between threads. What is the happens before relationship? Happens before is a rule in the Java memory model that guarantees memory visibility and ordering between operations. If action A happens before B, then effects of A are guaranteed to be visible to B. For example, if thread 1 writes the data happens before thread 2 reads the data, so thread 2 sees the updated data. So always thread 1 should happen before which the thread can view and use it. So that's what happens before relationship. So the next concept is about synchronized and versus reentrant lock. Both provide mutual exclusion. So synchronized, you know, if we have a method level or as a block level. So both are used for synchronization. In similar way, reentrant lock is also used for that. You can particular lock the particular block of code and execute and unlock it. So advantages: synchronized is very simple, built into Java, automatically releases the lock, rest error prone. The reentrant lock, we need to unlock it. So we have like a try lock. You have a timed locking. So if I want to lock within this period of seconds or something, so fairness option, multiple condition objects. So if you see here, this is the try lock with the seconds. So mostly the unlock will happens in the finally. If unlock doesn't happen, it is a concern. So synchronized is simpler and usually be preferred when basic mutual exclusion is sufficient. Reent lock is useful when I need just try lock, interruptible locking, timed acquisition. Within this period of time, I want to lock. After that, I want to release. Fairness or multiple conditions. Volatile the versus atomic variables. Volatile guarantees visibility and ordering constraints, but it does not generally provide compound operations atomicity. Atomic variables will do the increment of counter where the volatile will not produce. That's what here they are coming to say. We know atomic integer increment and get it use CAS technique like compare and swap. So you have atomic integer, atomic long boolean, and atomic reference. So when to use a volatile? If it is for a flag kind of a boolean variable or something, you can use volatile. To for a counter related stuff, you can use the atomicity. What is CAS and how does it work? Compare and swap. It is a log-free atomic operation. If current value is equal to expected value, current value to else fail. So if you it is kind of a comparison. I want to see whether it is expected value. If not, increment. If yes, so that's a comparison. If the current value is 10, increment it to 11. If the another variable, another thread changed it first, otherwise fail it. So that is the atomic variable. How does concurrent hash map is achieve thread safety? So I have a separate session for this concurrent hash map. I will put the recording in the description. For this concurrent hash map, always read it. Read is not a concern because everything will be in a separate bucket. So it always do the reading without has any problem. So how allow write makes that. So the write is about compare and swap. If you want to write it into a new bucket, there is no lock for that. Also, you can write it in the new bucket as it is. If it is a existing bucket that you want to write data, then it will lock only that bucket, and the other bucket will be free to write. So concurrent hash map does not lock for read, does not lock when there is a new bucket needs to be created to put a data. Only do when there is a, see, it is writing in the same bucket. So modern Java implement use for the gas and volatile operations, fine-grained synchronization, bucket bin level coordination. This is what I thought about bucket bin level coordination. So the compare and swap is used when, if it is a, whether the new bucket exists or not. For that, the compare and swap method is used. And the bucket bin level coordination is nothing but when we are writing, if new bucket is required, then only the lock mechanism happened. So this is the fine grain level synchronization, as it is which level we need the synchronization at that time alone it uses that. That is the fine grained synchronization. So multiple threads can operate concurrently. Why not hash table? Hash table is synchronized, but it operations completely, for each put and read and write, it logs the complete table. That is the reason hash table is preferred. Chief thread safety using fine-grained synchronization, non-blocking techniques such as CAS rather than locking the entire map. This allows concurrent reads and updates with much scalability than synchronizing a normal hash map. What is a race condition? Race condition is nothing but when two threads trying to access the same data, one and each other is depending on for one another. For example, here I have a class counter where I want to increment the counter variable. Initial count is 10, where both A, B reads the same counter variable and try to write the increment the same value. For example, as it is through thread, now it should be the increment should be as a 12, but actually at the same time it reads and writes, it becomes the value is 11, which is a wrong. This is called a race condition. How we can prevent the race condition? We can prevent the race condition using synchronized, as it is a counter. You can use atomic variables and log the necessary places alone. Mostly for increment, for this kind of counter, we can use atomic integer. But if it is a block of code, we can use the synchronized and logs. And concurrent collections, concurrent hash map, blocking queue, concurrent linked queue, all these things. The concurrent hash map will be used most for the caching related thing. The blocking queue and concurrent linked queue will used mostly when we whatever to store the received request and for further processing. Immutable objects like string and other stuff. Thread confinement. So this is the main thing. For as an interview assessor, I first try to minimize the share mutable state. If share state is necessary, I use the least complex appropriate mechanism. Atomic variable for simple atomic updates, synchronized or logs for critical sections, concurrent collections for shared data structures. So these are the ways, but we need to choose which mechanism to use for what scenario. That is the main thing. So here they are clearly given example. Atomic variables for simple atomic updates like increment, decrement. I'll use atomic variables. For critical sections, we can use synchronized logs and other things. For concurrent collections for the shared data structures. What is deadlock? So what is deadlock here is mainly deadlock occurs when thread wait indefinitely for resource held by each other. For example, thread A waits for thread B waits for thread A. So where one wait for another indefinitely cause the deadlock. How you can identify deadlock using the thread number. How do you detect and prevent deadlocks? If you see the thread dump very easily, you can see that there is a thread identifier for each thread. So from that you can identify that two threads are waiting for each other, one another. Okay. Deadlock versus livestock versus starvation. Deadlock, which we have said, the threads wait forever. Livelock is something each goes in a different direction. It doesn't even meet or doesn't even finish its task. The progress is goes on. For example, if if there is a s- state where both of them, thread A and thread B, wants to meet at the center, but thread A goes to the left and thread B goes to the right, there is no way they will come to the midpoint. They'll go in the opposite direction and there is no end for that. So that is called live lock. Starvation thread doesn't have a proper CPU resources. For example, I allocated three thread pool, for three, but I have more processing like 10 or 20, which there is a starvation comes. A thread doesn't get enough CPU or resource access. So where the starvation causes the increase in latency, all other things. A wait for B, deadlock is A wait for B, B waits for A. Imagine two people repeating to avoid each other. Person A moves left and person B. So this is one problem. Starvation threat A, B, C. Thread D rarely gets this. So these three itself occupying the one, the fourth cannot getting the resources or CPU. What is thread starvation? Starvation happens when thread continuously fail to get access the CPU connection thread pool worker. Okay, that is the main thing. So executor service versus fork join pool. Executor service is a general purpose task execution framework. In most of our application, we use this executor service. So you have the executor with the single fixed thread pool or some scheduler thread pool, that there are several thread pools available. So you can have 10 thread pools. So you can have at that time you can process 10 threads. So I would task background processing generally is for a general asynchronous task. So fork join pool designed primarily for divide and conquer stealing workloads. Like for example, I have five threads. I will share each one for laugh like task thread pool one for A task doing task A, thread pool two task B and thread C. If thread one first completes the first task, it will steal from the another pool the another set of tasks and start executes. So worker steals tasks from the other workers when it is idle. So how does thread pool executor work? The core idea task thread pool worker threads execute the tasks. So this is the pool size. What is the maximum pool size? What is the keep alive time? Q thread factory. So worker is create the worker. Queue capacity workers it's created. If it is not, it will reject it through the execution handler. How do you choose core pool size and maximum pool size? The CPU core size is the thread pool size is defined based on the uh, core, the number of cores in the system, and there are formula in the JDK level also that to use, but it is not appropriate in every application they use. It is kind of uh, trial and error method. So that is based on each application, it differs. So they are giving a CPU bound complex language processing encryption, reasonable certain number of CPU cores plus one. IO bound database calls all these things. They are saying cores into one plus they have the calculation of waiting time like slash compute time. So for the interview answer, I don't choose pool size purely from a fixed formula. That is really true. It and I know I worked in different application. It doesn't matches with the formula. For CPU bound work, I start around the number of available process, while for IO bound workloads, I allow more concurrency because workers spend time waiting. I then validate the configuration using load testing and production metrics. Really, this is the one really works. There may be a formula in JDK or somewhere, but it doesn't matches exactly based on the applications. Trial and error method. What happens when a thread pool executor queue becomes full? If become full current trigger, then executor may create additional threads. If the maximum pool size exits, then the task is rejected and the rejected execution exceptions will be thrown. Okay. The caller run policy. This is interesting because it provides a form of back pressure. Completable versus future. So completable future is one which is an enhancement of future. That is what we can say. Feature which used to get a return value from the thread execution. Complete future is one advanced where you can have multiple asynchronous tasks you can do. Then if from the result what the other processing can be done is that completable future. It is not equal, it is not that equally comparable. It was an enhancement of future is what I can say. So future is equal to execute submit, you will get the result. It is a blocking, you will do one by one. The completed future is an synchronous where if you see here it is supply async, you get the user, then the result can be applied to the user dot get name, then accept print this one. So it is a asynchronous mechanism and it has multiple combination of processing. You have to submit and you can get only the result, but you have multiple methods here. You can build task A, task B, task C without manually blocking between each stage. Okay. Composition, it does exception handling also. We don't have any exception handling in future. Here, compatible future has the exception claim handling. Combining task like then combine, like then supply, there is then combine method to combine the task. It has callbacks, then apply or something like that. Async pipelines, it can do the async, then supply async. So there is a pipeline kind of a mechanism that it is possible. Future represents the results of asynchronous computation, but it is largely blocking when retrieving the results. Completed future provides us richer asynchronous programming model with composition, callbacks, exception handling, and parallel task combination. So, how does in completable future work internally? Completable future represents a computation that may complete in the future conceptually. This is a async supply, then apply. So internally completer maintains completion or dependency structure used in executor mechanism to use asynchronous stages. If no executor is explicitly supplied, if we are not giving any executor, it will use the fork and join common pool method of asynchronous operations, which is a divide and conquer. Okay, but it is for production kind of environment. It is recommended to use executor. Okay. Then apply, then compose, then combine. These are completable feature methods. What it is, the difference. Then apply, transform the results from the earlier method. For example, I have user future get user. I want to process this apply as user future dot then apply to get some name. So what it will do, it will use the same executor of that. Then compose used when the next operation itself returns a completable future. So without compose, if you return something, you want to use something kind of this. If you are using with compose, you can just use this one. That is what they are coming to say here. Then combine. Then combine means you are combining the results of two and creating a new response. So A, the process of A future or B future, and then you are combining the results A, create response of A, B. A and B is combined. So what is countdown latch? Countdown latch is something like of a counter mechanism of number of threads is used. For example, I am creating my thread. I want to have the process to count down what operation has been completed. So at that time, what it will do here is allows one or more threads to wait until the counter reaches 0. So worker thread, when I say workers, wait it a countdown and waiting the thread. So worker round down will do count the number of, if it is 3, here the 1 to meal reduced to 2. Here it will become, you know, or 1. Here it will become 2. Here it will become 1. And after this one, it becomes 0. So it waited for the number of period of time 3 times. So then it becomes 0. What is cyclic barrier? Countdown latch, it says to wait for n number of times. The cyclic barrier is something like if thread 1, thread 2, thread 3 process and it wants to come into a stage where 3 threads combinedly work for the move to the stage. For example, I have thread 1 has 7 stages, thread 2 has 5 stages, and thread uh, 6 has some stages. After reaching all threads reaching so one of a stage like 4, then only it will process to the stage 5. So once all these thread went to this state, it will wait. And once all thread reaches to the state of 4, then only all thread execute for the further process. That is the one example here. So latch example, wait until 5 services initialize. Barrier phase 1, all threads reach barrier. Phase 2, all threads reach barrier, and then move to phase 3. So this is the example. So thread want to go to some state, wait, and then go to the next stage, phase barrier. What is semaphore? Where would you use it? Semaphore control access to a limited number of permits. The countdown latch and semaphore is simply different, where countdown latches waits for some period of time and then you know completes its asynchronous execution. With the semaphore, what it does is it allows only the number of times to acquire. For example, if I mention 10, still 10 that the process can be acquired, and then it will wait for the, 10 10 concurrent operations can be done. Once all the 10 operations completed, then only then the 11th. For example, more than 10 concurrent access cannot be done. That is a main thing here. For external API, database resources, expensive operations, we will use semaphore. What is spacer? Spacer is a flexible synchronization mechanism for coordinating multiple phases of works. It is more flexible than countdown latch and cyclic barrier. Countdown latch wait for some 3 number of times, and after that it will complete its process. Cyclic barrier, repeatedly it will wait. For example, I want to all threads should complete phase 1, then wait, and then process phase 2 and wait, then process phase 3. So it may have different number of tasks and different, but there is a phase where it should wait and then move to the next phase. Is that not the cyclic barrier? The pacer here is about performs phase works, then produce to the next phase. But there, when the number of participants here in cyclic barrier, the phase will be 1, 2, 3. But here the number of threads can differ. Mainly the execution will be like the number of items ordered, the number of items built, something like that. What is thread local? Thread local provides thread specific storage. For I told you always thread local have a thread will need a thread local variable for specific. If there is a thread A and thread B, Thread A will have its own vehicle variable, thread B will has its own variable. For that purpose, we can use thread local. But the main thing is, the important thing to be remembered is after usage of this thread local, it needs to be cleared. Otherwise, the memory will not vanish. What problems can thread local cause? Case issues with the thread pools. Request A, thread pool A, thread local user A, request completes the thread pool thread 1, request B, still the thread load contains local contains the user A. So you should clear the variable, otherwise it causes memory leak, data leakages between the requests. So always we need to clear the thread local once after it is used. What is fault sharing? Fault sharing is nothing but it is not a programming concept, but it is based on the programming. It is where how the storage happens for the thread. So fault sharing is a CPU cache performance problem. For example, thread 1 and thread 2 has variable A and B where it is stored in the same cache line, variable A and variable B. But when core 1 updates A, the cache line as it is the same line, cache variable B become invalidated and variable A will be validated. When core 2 writes, variable B will be validated and A becomes invalidated. So when one updates another, another thing became invalid. This is becomes A unrelated to B. It can come creates cache contention and performance degradation. So mostly this can be resolved some using some padding, all this concept. But you can know what is fault sharing is the concept that we are explaining. So what is fork join pull, which is we already explained. Fork join implement is a work stealing method. So worker 1 queue has A, B, C, D, worker 2 has E, and worker 3 has F. Once worker 2 and worker 3 completed its task, it steals the job from worker 1, which it is not idle. Okay, for example, here they are saying worker 2 finish its work since instead of it's waiting identical, it says steals D from A. Okay. This improves CPU utilization for parallel thread. It is mainly used for recursive task driven and conquer algorithms, parallel computation, and parallel streams. So, how do parallel streams works? Parallel streams generally use fork and join poll, splits data into partitions, and workers important. Parallel streams don't necessarily mean faster execution. It is task splitting, scheduling, synchronizing, and combining results. Why can parallel stream hurt performance? Several reasons. Small datasets, 10 elements, the overhead can exceed the benefit. Parallel streams are generally not good choice for blocking external operations. This can overload APIs, database, and connection pools. They are saying the caller pool should not use for to call APIs or database related stuff. And also it is not used for the shared state. So how do virtual threads works internally? I have a separate session for that, which I will add it in my description for you. How do virtual threads is a, it is a kind of a thread that is used in the JVM scheduler and it executes the task. For example, thread A executes the task, and if there is a blocking or operation where it is the one, the virtual thread holds the state of all the data, and the OS thread becomes free to execute the another thread which needs to be done. So the OS thread is utilization is good when we are using virtual thread is the main concept here. Okay. So this allows a relatively small number of carrier threads to support a very large number of virtual threads. Okay, when should you do not use virtual threads? As I mentioned earlier, virtual threads are always recommended for all scenarios. There are scenarios when it becomes overloaded for the applications are not virtual threads are not a universal replacement for platform threads. Void them as a solution for CPU bound workloads, huge mathematical calculation, video, CPU intensive encryptions. Virtual threads don't increase CPU capacity. So native blocking situation don't use virtual thread resource limitations, you know. So you can't do the 10,000 database operation at parallelly at that time. Don't use your this one. So I wouldn't use virtual threads simply to increase CPU parallelism. They are primarily a scalability mechanism for high concurrency blocking workloads. I would still control the downstream resources such as database connection, external APIs, and rate limits. Virtual threads versus completable features. They solve different problems. It is not equally, kind of equal comparison. So, completable feature focus on asynchronous composition, get user, then compose, and then apply. Virtual threads focus making blocking style concurrency cheap. How do you handle blocking operations with virtual threads? So one of the major advantage of Vectors is that blocking APIs can often be used naturally. So this is the way, so for example, new virtual thread per task executor, you can use it internally to create the orders and get orders. How would you debug a production thread issues? So whenever the thread issues occurs, there are different kind of issues occurs. It may be, race condition, deadlock. Race condition mostly you will can identify based on the log. Here I have added some examples, but I'm giving through my real-time scenarios. For example, race conditions can be mostly identified through the having a lot of debug log statements, because the state clashes happens a lot, and deadlock situation can be identified from the thread dump. The other exhaust the thread resource exhaustions can be identified from heap dump or GC logs, not in GC logs, the heap dump or some other profiling mechanisms. So each there are multiple thread issues, and it can be identified in E based on the issues and the problem. So here symptom first you want to identify what the problem, whether it is a high CPU issue or high CPU and high latency always will be somewhat related. When the CPU increases, latency also increases a lot of times, and requests hanging, thread pool exhaustion, deadlocks. Each one has a different way to, you know, debug the concerns. Okay, so for all these issues, you want to look at the CPU, memory, GC, request latency, thread count, active threads, queue size, requested tasks, capture thread dump, compare the dump. These are the main state that you look for: blocked, wait, timed waiting, runnable. You will have also thread identifier in the hexadecimal, which you can identify the thread ID, and use JFR like thread activity, CPU lock allocation, IO synchronization, correlate with the application metrics. How do you investigate high CPU caused by Java threads? First, you want to identify which thread is in the high CPU. You can identify that using top or hash top command, and hide CPU thread IDs from the thread dump, and yeah, JFR and other profiles that you can look for the next one. How you can identify the thread pool exhaustion using the exceptions and all other things, and also using the heap dump, you can identify what are the other causes of the mechanism. So how do you design a catchy? For mainly for catchy, for all application, for a very local, you can use concurrent hash map. If you need to there are other lot of things like eviction, all this to be happen, it is best to use the 3pp like Hazelcast, Redis, or other catchy mechanism that we needs to use. But if it is a simple catch, you can use it to the concurrent hash map. Okay. Suppose a popular entry expires due 100 dB calls population compute per locking request. So these all things to be like taken care during this one. These are Redis caffeine distributed caches or some example of the real 3pp's. So I told you need eviction, you need the statistics. Statistics means how many number of entries cached, how long period it needs to be cached, when it needs to be evicted, how. So for all these things, it is better to use the 3pp, but it is not necessary for all catch you need that. There are a scenario where we will use the concurrent hash map also. So describe a real world concurrency problem. There are a lot of problems you might solve in your real time scenario. This would be one of appropriate. I have not given an answer because it depends upon your thing. So whenever you say the problem, say the impact, what are the investigation you done, what is the root cause, what is the solution, how many percentage, or for example, all the concurrency of problem will might result some improvement, and what the lesson you learned from that. So you can structure your answer based on this and you can answer. Okay. So yeah, so that is from my side. This is the 40 important multi-thread interview questions. So thank you. If you have any questions on my explanation, you can ask me in the comment. I would see and reply for you. If you need any further important topics also, give me as comment. Thank you.